Please, in the chat, wherever you're watching on Zoom, Twitch, LinkedIn Live, YouTube, or even for some reason on Facebook, let us know where you are joining from. We love to see the global OpenCV audience chiming in every Thursday morning here on OpenCV Live. I am coming to you today from beautiful, way too warm Tijuana, Mexico. Doc, where are you coming from today?
San Diego, California. And it's getting warm here too.
The usual places, the usual places. Mm-hmm. I am fixing our Zoom feed real quick. It seems like, okay. Yes, that was the problem. Sorry, Zoom. Well, I can't apologize to them because they're not involved. They're not in here yet. But all right, Zoom is now live. We should be good everywhere. I know this is super exciting to watch a guy push buttons you can't see, but we do have an exciting episode for you today. We've got our very own Dr. Satya Mallick will be giving us a tutorial on the Qwen 2.5-VL multimodal language model from Alibaba Cloud. I think a lot of people out there that aren't super clued in to the computer vision scene, as it were, may not realize that Alibaba has such a massive AI infrastructure within the company at this point. I think if they know about them at all, most normies out there know that they're the even cheaper version of Amazon, basically, right? Like, it's where you got to find like the weirdo knockoff electronics components and stuff like that. So. But no, they're a massive company, and they have.
And the thing, and the thing is that they are also, the solutions, they have chosen the open source path. So the weights are open source. It's really, they're doing a very good job. And one of their pet peeves is that our models are so good, but somehow people don't they don't reference us in papers. Right, everybody outside the papers, right? Everybody knows that the models are really good. For some reason, they don't get mentioned, right? So it's one of those things that sometimes it is just sad that people don't get the attention that they deserve. So we will give Qwen some attention.
We know all about that here at OpenCV. It's something we discuss quite frequently. Zoom looks like it's up now. Hey, everybody on Zoom. Sorry about the late start here today. I am not in my wizard tower floating high above Soma in San Francisco, California, but instead in Tijuana, Mexico, the happiest place on earth, as Krusty the Clown famously called it. And it is that for me. I must say, every time I come here, something else impresses me about it. Especially the food. The food in Tijuana is fantastic. If you ever get the chance, definitely cross the border and have a visit. It's a really interesting place with awesome food and extremely cool people. But yeah, Zoomers, let us know where you're joining from, because you missed my little early preamble there. Looks like we've got some folks coming in from Nigeria. We've got Baha. Hey, howdy Baha. UAE chiming in here. So yeah, let us know where you're joining from. I know we started a little bit late, and we're also having maybe some small video issues, but it looks like we are in fact live everywhere. And so we'll get started here. I think, Doc, if you're ready to go, let's go ahead and do it. Do you want to talk a little bit about OpenCVU at the top after your intro?
Let me officially start it. Right. Hello, everybody. Welcome to OpenCV Live. In today's episode, we are going to discuss Qwen 2.5-VL. This is a large vision language model where we will discuss what are the capabilities of these model and how to do image captioning, object detection using this model. Very powerful model, as you will see. But before we start, we also have with us Phil Nelson, who is the Director of Content and Creative at OpenCV. He produces the show. If anything goes wrong, it is his fault. Hi, Phil.
Howdy, Doc. Good morning out there, everybody. Yes, it's me. It's PHI-LLIP. I am the co-host with the co-most, the second banana who's second to none. I am also your plus one and only. It's Mr. Nelson. If you're nasty, but you, my dear friends, can call me Phil. And I'm here to remind you of a few things that we do on every single episode of this here program. The first of which is a giveaway to you out there in the audience. Stay tuned. Later on in the episode, I will be asking a trivia question based on the presentation by our illustrious host, Dr. Satya Mallick. And the very first person to answer that question correctly will win the OpenCV University course of their choosing. We've got a little bit more to say about OpenCV University in a few minutes, but we're also taking questions from you in the audience. Use the Q&A button wherever you're watching. In the chat, just type your question, or if you're on Zoom, hit that Q&A button. Save those questions for us. In about 40 minutes or so, we'll do Q&A afterwards, after we do our trivia segment. So stay tuned. We like to reward people that pay attention. If you want that course, watch the episode. Remember what the doc says, and you too could win. But to start us off here, let's briefly discuss. We've got some big OpenCVU news here. I'll bring the screen share up.
Yeah, so the
Tell us
Labor
about it,
Day
Doc.
sale has started. We started early. That's why it's called Early Bird Special. This Early Bird Special is going to end tonight. So if you're interested in OpenCV courses, this is the absolute best time to start. So the thing that I recommend is, it's a collection. If you're really serious about a career in AI, then the best option available for computer vision and AI is our computer vision and deep learning master program. So this is a collection of 6 courses, and it basically has all the courses that we offer. And there are 2 courses out of these 6 courses. There are 2 courses that are super important. It is Fundamentals of Computer Vision and Image Processing. This is a Python-based course, and we also have 2 deep learning courses. You can do any one of them: deep learning with PyTorch or deep learning with TensorFlow and Keras. And these are serious courses, right? These are not like your normal courses where you go and finish it in 7 days, right? These courses will take you solid, like each course will take you about 3 months to complete. But after you're done that, you have a very solid foundation of what computer vision is, and also about deep learning, right? So 3.5 months for computer vision course, 3.5 months for the deep learning course. That's about 7 months, and maybe a 1 month for just as a cushion there. So in 8 months, you have a very good shot of calling yourself an AI expert. In fact, I can say without hesitation that this course is better than 99.9% of the courses out there, including top university courses. So this is a very good deal also. Right now, if you look at the pricing, 40% off, that goes away tonight. So if you're interested, please go and check it out. This is for serious people, right? If you just want to dabble in computer vision, then this may not be the right choice for you. But if you are serious about getting expertise in computer vision and AI, this is the absolute best program for you. In addition to this, right, so people who go and purchase this program during this webinar, and you can let me know in the chat section, you purchase the webinar, just give a screenshot or something, or just send us an email at courses@opencv.org. I will send you a special gift, right? This is a webinar only special, and this is basically a book by Francois Chollet. This a $48 value, and this book is called Deep Learning with Python, and we'll give you this book for free, right? But you have to purchase. This is not included in this webinar, in this sale, Labor Day sale, but I have this very special webinar offer for you. If you purchase it during this webinar, before this webinar is over, and send us an email at courses@opencv.org, you will get that book included in this program. All right. So let's get started. We have a very exciting.
Sweet deal, Doc. Yeah.
Do you have other things to cover before we get started?
No, I think we should just get going here. I'm gonna take myself off cam and turn the show over to you, Doc.
All right. So let me share my screen. How do I share my screen? Okay, right here. Share screen. And we are going to start with, can you guys see my screen? Uh, can people see my screen?
Yeah, you're all good, Doc. Sorry about that. I was muted out for a sec. I'm having some AV difficulties here, but go for it.
All right, no problem. So, okay, so Qwen 2.5-VL. First of all, what is a vision language model, right? Now, um, a vision language model is basically a model, right? We some of you may know, or most of you probably know, what is a large language model. A large language model is an AI model that has been trained on internet scale data, right? So we basically took all the data from the internet, all the text data from the internet, and created a single AI, right? AI model that is so large that it basically encodes all the information, all the world information, and you're able to answer, talk to it, right? So that's a large language model. But of course, we know that text can go only so far. We also need to include images and videos, and that's where vision language model comes in. So if you look at traditional computer vision algorithms or neural networks like image classification, let's say you want to build an image classification model, you give it an input, and the neural network basically would tell you what the output is, right? It could, in a standard classification problem, the input is a dog, and or the input is an image, and the output is a class label, right? And you have this neural network that you train. And for training this neural network, you take several examples of dogs, cats, horses, whatever you want, whatever classes you want, and you basically train the neural network. You have the ground truth also. You also know which image contains what, right? So image of a dog, you have the label dog. Image of a cat, you have the label cat, and so on and so forth. And then you train a neural network, usually an image classification network, like let's say ResNet 50, and it will be able to tell you information about those classes only, right? So let's say you had 50 classes in your training set, you would be able to get 50 classes. You'll be, if there is an image of that class, it will be able to classify that, okay, this is a cat, dog, etc. But this is a very limited way, because it doesn't know anything outside that class, right? And just imagine, if you give it, let's say there were no elephants in the class, and you gave it image of an elephant, it would either classify it as one of those other 50 classes, or you could have a catch-all, unknown class, and that's the best it can do, right? It cannot automatically figure out that it's an elephant. However, if you had trained a vision language model, right, and a lot of these models are trained on image caption pairs. So they go on the internet, they find out, okay, this is an image, there's a caption. So this vision language model, because the language part is there, it gets world knowledge from the language part. It is able to infer what an elephant is, even though you had never explicitly trained it to recognize elephants. The vision language model would be able to recognize elephants because it has been trained on internet scale image caption pairs, right? So that's the basic difference between VLMs and traditional computer vision techniques like CNNs. Now, using CNNs, right, the normal image classification techniques, both worlds, right? So vision systems, when we analyze an image using, let's say, a convolutional neural network, we get features which know a lot about that particular image, right? So we learn those features, and that's the vision part. So you are able to very closely analyze what is inside this image. But at the same time, the language part, because it has been trained on world knowledge from the internet, you're combining that world knowledge with local information. So the vision part is getting local features, and this LLM is basically helping you get global context. So you are able to do so many things which were completely, it almost looks like science fiction now, right? One big difference between traditional methods, right? Or it's funny, I'm calling them traditional methods now, but they are pretty new techniques, right? So let's say image.
Traditional methods of so long ago,
Right.
like 5 years.
So now think about image classification. When we say image classification, the input and the output, they are constant, right? And only the neural network architecture changes. When I say that ResNet 50 is an image classification network, you would immediately know what is the input and what is the output. Okay. Similarly, when I say, okay, we trained an object detector, you know that the input is an image and the output is a collection of bounding boxes with labels. So there is no ambiguity in what an object detector does, or what an image classification network does, or a segmentation model does. The input and output, as soon as I say that I have an object detected, you are very sure what it actually means, right? But that's not the case with VLMs. The VLMs, they could mean many different things, right? So for example, a few weeks back, we had done we had done an episode on Clip. So the architecture of Clip, the inputs that were given to Clip, the output Clip gives is completely different from Qwen 2.5-VL. They are completely, except for the word VLM, that they are both VLMs, they are both vision language models. There is no similarity between the two, right? So this is something that you have to bear in mind, that this is not like when people talk about VLMs, they can actually talk about many different things, right? The only thing constant among them is that the input is image plus, sometimes even the input is not the same. But if you look at modern, the more capable VLMs, usually you have an input which is image plus text or video plus text, and the output is usually text, right? It can also be an image, but for simplicity, we can just keep it text, right? And so today we are going to talk about Qwen 2.5-VL. Now, even though in this diagram I say that, okay, we can have image and text, usually everything is encoded in a prompt, right? So the prompt encodes the image, the text, the video, whatever you want to give it, it is encoded in a prompt, and then we have the vision language model in between, and the output is text. So we'll show you the exact syntax, how it is done in using Jupyter Notebooks. But let's first look at the capability, right? What is this vision language model capable of? What you're looking at, this input, right? This input has 4 images in the same image. And you can ask Qwen 2.5-VL, what are these attractions, right? We are not giving one attraction at a time. This is a complex image. It has 4 different images embedded in it. And we are saying that please give the names in Chinese and English, okay? And if you do this, it will output this kind of thing. It would say the Great Pyramid of Giza, and words in Chinese, which I'm assuming are the Great Pyramids of Giza. And similarly, right, it would say the top right, we have the Great Wall of China, bottom left, the Statue of Liberty, top right, the Terracotta Army. Now think about it. There was no training involved. The model is so capable that you give this complex image, it figures out the structure, the layout of the image, that it's not a single image, but a collection of 4 images. And then it is able to say, what are the various things, right? What are the various attractions? So this is a very powerful capability, which, just a few years back, it was not possible. In fact, a year or 2 back, it was not possible. Now you may be thinking that, oh, I'm going to use VLMs for everything now, because why would I use why would I use image classification or object detector when I can just throw a VLM at it? The problem is these are very heavy models, right? You cannot use them. You can use some of these models on the edge, right? But they require compute and things that can be done. So don't use a very big hammer to solve a small problem, right? Use the right tool for the right task. So there are things where you just don't have enough data. If you have no data at all, then start with a VLM. And if you have data and you have to solve a very specific task. For example, if you're building something for a manufacturing inspection in a manufacturing plant, then you know the kinds of defects, right? And the VLM may not have that level of knowledge, right? That okay, this is a defect, because who knows, right? That manufactured plant, only you know that a defect looks like this, and you may not have many examples of that defect, right? So you are much better off training in an image classification network and solving that problem. So use the right hammer for the task, right? The right tool for the task. Don't, because these things would be very expensive to run if you actually use them. Okay. So here's another example what Qwen 2.5-VL is capable of doing. You're looking at a picture, okay? And you're asking the VLM, detect all motorcyclists in the image and return their locations in the form of the coordinates. And then we are giving it the format, right? We want bounding boxes 2D. This is the format. It has a label and it has a sub-label. The label is motorcyclist. The sub-label is wearing helmet or not wearing helmet, okay? And if you run it on this particular image, you will see this output, right? So you can see that all the motorcyclists have been identified, and it also the coordinates have been identified, and it says not wearing helmet, not wearing helmet, not wearing helmet, and then wearing helmet. You would expect, in a street scene, most of them would be wearing helmets, and then there would be one which would be not wearing helmet. But I'm guessing that this is a scene from Asia. In fact, when I was growing up, they would nobody wore helmet while riding bikes. So it's just funny that you would not see this kind of scene in the US. Um, but yes, it did find all the classes as well as the subclasses, right? And now you can use this model. Uh, Important thing here is you never train this model on helmet versus not helmet. You never trained it explicitly to detect bikes, right? So it has figured out by the training process that these kinds of things are helmets, these kinds of things are bikes, and it also knows how to localize this information, right? So it is fascinating what it is able to do. It is almost like science fiction. One thing I would like to point out is that some of these examples have been run. The Qwen 2.5-VL comes in many different flavors. So the biggest model was used to produce these examples. So sometimes when you use a small model, which you can do on Google Colab, you may not get the same quality results because it's a small model, not as big for which these results were generated. It also understands, because of the language part, it has a sense of what the social structure is, right? There are a lot of when we as humans, when we interact with other people, there are a lot of social information that we absorb from the environment, which doesn't need to be explicitly taught to us, right? The same thing happens because of the scale at which these things are operating. They understand the context, right? The social context also. For example, in this case, you are given an image and it is said, you ask it, which person is acting bravely in this case. There's a lot going on in this image, right? It needs to know that, first of all, it needs to completely understand that, okay, there is a knife, there is a person, he's threatening a woman, and there is another person who is trying to save, right? But not only that, it also needs to know the idea, what bravery is, right? What courage is. It needs to have absorbed that idea as well, right? It is not just that you can locate all these things, right? That is that is a mechanical process, right? That is doable, right? You can understand that. But to identify that in this context, this is the person who is acting bravely, that is quite something. It gives you a glimpse of intelligence, right? Not AGI or anything, but still a glimpse of intelligence. However, it makes this decision. You may say that, oh, it's just doing some calculation. Yes, our brains are also doing similar calculation, but you can see that there is a glimpse of intelligence here. Okay, and another task which it is very good at. In fact, in our consulting, we use Qwen 2.5-VL for document whenever there's a complex document parsing, um, and we have to use VLMs. In that case, Qwen 2.5 VLM is our VLM of choice. So it's very good at document parsing. You can, in fact, in this example, you can say that, okay, convert this document into HTML format, right? That's something. But you can also say, give me the summary of figure 1, right? Or what does figure 1 say, right? Or where is this figure which does this, right? So you can have very complex document analysis that this thing does, and it can also structure your document, PDF especially. It can structure your PDF, extract information from the PDF very nicely. So if you're thinking about building a document parser, this may be a very good option. So so this is very interesting. And then it can also analyze videos. Okay, so this is a video which where they want to localize particular events. So what's happening, you can basically say, put in this video and say that localize a series of activity events in the video, output the start and the timestamp for each, right? So let me show you. I think I'll have to restart my sharing because it is on a different
Go for
tab,
it.
right?
We'll make it work.
Yeah, 1 second. Let me share my entire screen instead of just entire screen. I will share screen 2, share. Okay, so you can see that now, right? So in this video, right, after you give this prompt, it goes and says that, okay,
There it is. Yep.
at start time 21 seconds, a person removes a piece of meat from its packaging and cuts off the fat. So, okay, let me go to the video. Where is the video? Yeah, right here. So let's go to 21 seconds. So you can see at about 21 seconds, let's start again, sorry. So the person is removing 19 seconds, the person is removing 21 seconds, they removed it, put it here, and then they start cutting the meat, right? And the fat. For my vegetarian friends, I'm sorry. And for my non-vegetarian friends who are salivating, I'm sorry as well. But yeah, so basically it is able to identify various events in the video, right? And it says that at location 50, the person is seasoning the meat with salt and pepper. And if you go and look at about 50, let's go here. So it's not actually salt and pepper, it's oregano or some other, you can forgive it, right? At least it is a kind of spice that they are putting it on the meat. So these are the kinds of very sophisticated long video analysis that you can do with Qwen.
You don't do much cooking, do you, Doc?
Why? Is it salt and pepper?
Yeah, just wondering.
Well, because I'm not using the correct language of cooking. All right. So video analysis, right? So it does a very excellent video analysis. Now, bear in mind that these results, you will get this quality result if you are using the biggest model, right? As the size of the model comes down, you should pare down your expectation also. Okay. It can also do, sorry. Okay. And it can also do agent action. Now, in the context of VLMs, uh, agent usually means when you want to do something, when you want to control your laptop screen or your mobile screen using the outputs, right? You basically you take a screenshot of your laptop, right, or your mobile screenshot, give it to the VLM. It will automatically figure out what the layout is and what are the various apps you have and what are the various things going on. And let's say you start a browser, it will know that, oh, you are in a browser just by looking at that image, and it will be able to do the next task. So you can say that, oh, make a reservation for me at my favorite restaurant, right? Whatever the restaurant is. So it will go to the browser. It's going to start the browser and then look for the favorite restaurant, go near your location, etc., etc. So that kind of thing is called agent action, and this is able to do that as well. So okay, so let's look at the usage, right? How do you actually use the VLM? The Qwen 2.5-VL, it is you interact with it using a chat interface, right? The good thing is that you can chat with it several times. You can give it the context. There are the chat looks like this, right? Hopefully, most people are familiar with JSON format, right? JSON is, a text format where you can pass structured data using this format. So here we first, the chat interface looks something like this. It is called chat.completion, and we'll see very specific examples. You have the model. You say, okay, I want this particular model, and this model comes in many different flavors. This is a 7 billion model. You can also have the 3 billion parameter model, and so on and so forth. And based on how many parameters it has, the quality will be different. Then this is the crux, right? The main thing is the message that you're going to pass to Qwen. There are two kinds of messages. Actually, there are three kinds of messages, but let's for this we can just focus on one or two. So the first one is called the system, right? The system prompt is telling it at a high level what it is, right? It's giving it an identity that you are a helpful assistant, right? Um, and this is the kind of the kinds of things you put in the system prompt is something that you would ask again and again. Okay, so for example, when we do object detection, the system prompt could be, you are an object detector that returns the response in a JSON format, and then you can say what the format is, the bounding box format, etc. So once you set these things in the system prompt, you don't have to go and change, say that again and again in the user prompt, right? So user prompt is usually reserved for things that you want to get done immediately, right? So the system gives it an identity, and the user prompt is telling, it is requesting that I want something done. So here you can see that the user prompt, we are passing in an image URL, and there are different types also. The content that gets passed, it can be an array of different things, and this array could be many different sizes, right? You can pass in one image, two images, multiple images in any sequence you want. Okay, uh, but when you're passing image, you can pass it an image URL, and then you can also pass in a text. Okay, so here you can say that, okay, this is the URL, and all I want to know is what's inside the image. So what is the text in this image? So you can send like that. You can see how simple the user interface is, right? Using just this prompt, right? You can make it work. No other knowledge is required. So system, as I had mentioned, that it sets global behavior, right? And you say things like, you are an assistant that answers briefly, returns currency in USD, right? Let's say you are doing receipt analysis, right? You got a receipt, and you want to, even if it is, let's say, a Japanese receipt, you want the output to be in USD format, right? Dollar format. You can tell it in the beginning, and it knows, right? Then the system prompt sets the stage. It gives it an identity. And then you can say that uses JSON where a user asks for structured data. So here's another example of user, right? I already mentioned what it does, so we'll just skip over it. But in case of the receipt example, you can pass in the receipt and say, how much did the latte cost? Give the answer as JSON. This is not required because we have already put it in the system prompt, but it doesn't hurt if you're asking the same thing again. And it will give you the answer. Even if the receipt is Japanese, it is going to give you the answer in USD, right? So very simple, right? You didn't train the model, you didn't do anything. You took this model and just passed a prompt, and it is able to give you an answer. And you can do this right today with on your laptop, as long as it has enough GPU. I mean, it will still work, but it may be slow if you do not have a GPU. But you can definitely do it in Google Colab, and I'll show you how it is done. Okay. So model card.
Maybe send the prompt to go make a sandwich, go get some coffee or something. When you come back, it'll be done.
Right. So this is a 3 billion parameter. The model that we are going to show in our demo, it is a 3 billion parameter model, and it is multimodal. Whenever people talk about multimodal in AI models, it just means that it is capable of taking more than text, right? So text plus image or video, that's multimodal as well, right? And if it sometimes more sophisticated models would take in speech as well, so that's truly multimodal. Produced by Alibaba Cloud Team, which is also called the Qwen team. The Qwen license, you have to be a little careful about. It is, it's a research license for non-commercial purposes. And the 3 billion and the 72 billion sizes, they are not Apache 2, right? But if you want to research it, you want to, you can use it for a lot of things, right? When you're building a model to understand the model. So that's good. All right. And the weights are open source, right? So which means that you can actually use it in your notebooks, etc. Now let's start with image captioning. You guys are able to see this screen, right? It should be showing a notebook now.
We see the Google Colab notebook.
All right, perfect. So let's start with one example, right? We will start with. Let me make sure that I have finished. Yeah. Oh no, I had not finished the. Okay, sorry. Let's keep going. One of the things that people may be thinking whether whether it will fit in your GPU or not. So Qwen 2.5-VL 3 billion, right? This is going to take about 3.5 to 7 billion. Sorry, 3.5 to 7 GB, which means that an RTX 3050 should be enough. And the slides will show you all the different categories that it will. If you're using a bigger model, you basically need a GPU with a bigger memory. These slides and everything, right? All this information is in our free VLM bootcamp as well, right? So these slides are there. You can register for our free VLM bootcamp. Just search for OpenCV VLM bootcamp, and you will find all this. You can register for the free course, and you should be able to start it.
Or you can scan the QR code that's up on your screen right now if you're watching this show live, and find it on the OpenCV University homepage navigation.
Yeah. In the interest of time, actually, let me just skip some of this very quickly. It can do image captioning, object detection. We'll see this as well. Universal recognition, which we saw an example of. Again, object detection, different type. So we have pretty much covered this. Okay. Okay. So let's go look at image captioning. Here we are going to use a Google Colab, and I'm going to use a 2.5. So if you're using Google Colab for best results, right, you can go here and check what is the runtime you're using. So the runtime if you're using Colab Pro Plus or Colab Pro, you will notice that you have a GPU option, right? A100 is the most powerful GPU here, followed by, I'm guessing, I always get confused between the two. I think the T4 is the second powerful, and L4 is the least one. But you should use a GPU if you have access to it. Otherwise, things will be slower, right? So you can go and use this runtime. Another thing about Colabs or any notebook in general is usually, many people don't use this feature. There is this table of content. If the notebook is prepared properly, which in our case, we take great care to prepare the notebook, you will see this table of content on the side, which makes it very easy to go and navigate the notebook. All right. So the very first thing we need to do is install Qwen VL utilities, right? So we pip install this, and we should be good. One other thing is that 2.5-VL, it's going to fit in, it consumes about 6 GB of RAM in float 16 format. And I'll show you how to use it in float 16 format as well. So, most GPUs 3090 and above should be able to handle this. We start with standard imports. Not going over these. Most of the people on this webinar should know most of these, right? The only thing of interest which can be new to you is we are importing, right, the transformers. So transformers is this library by Hugging Face, which is an excellent package for Python package, which has access. Using this, you have access to pretty much all the large language models, regular models, all kinds of models in this package, and it's very nicely done so that you don't have to do repetitive tasks again and again. All the gotcha things where suppose you did not do the right pre-processing, etc., is taken care for you. It does under the hood. It does a very good job. So from there, we are going to get this Qwen 2.5-VL for conditional generation. And we are, this is a package we are importing, and also auto processor. Now, auto processor basically does pre-processing. Let's say you have text. The text, a large language model is not going to take text as input. So you need to tokenize it and then send it to the large language model. Now, tokenization, as we had covered it in the previous episode while discussing CLIP, it is basically converting text to a numerical representation. A token is roughly speaking, it's a word. Okay, so you can pass if you have a string, you can convert it to numerical values. For pretty much every word, you will get one number, and that process is called tokenization. Now, you don't have to do it because you have the auto processor which will do it for you. All right. And then we have, standard imaging and visualization. And then this one is the important one. We want to download Qwen VL utils, and we get the process vision info. So this basically does the post-processing. This basically does the post-processing of the model. The model output may not be in the format that you want, because so we can do some post-processing on this to clean up. All right, so the very first thing we need to do is we need to set the device. If a GPU is available, then we use the GPU. And CUDA basically is it's specifically NVIDIA GPU. CUDA is the library that is run on NVIDIA GPUs, and whenever we want to refer to NVIDIA GPUs, we say CUDA, right? And if CUDA is not available, if an NVIDIA GPU is not available, then use the CPU, okay? And then we basically tell the model ID. This is 2.5-VL 3 billion instruct. For people who do not know, whenever there is a model has the name instruct in it, it means that it is a chat-like interface, right? You can interact with the model in a chat format. If the instruct is not there in a large language model, it means that it is a raw model, right? It is most of the time you would not download those models. Those are for researchers who want to use the raw output and not this additional instruct model. Okay. Then we set up the model. We extract the model using this Qwen 2.5-VL for conditional generation dot from pre-trained. So look at this, how easy things are these days, right? You basically can extract this model by all the tools available. So you give it the model ID. Not only that, you also say that I want to automatically figure out what kind of data type this model should be in. Usually when you get the model, that would be in float 32 format, right? But you don't want things in float 32 because there are float 16, FP16, which will run much faster on the GPU without much loss in accuracy, right? And when you say auto, it knows, okay, FP16 works very well on GPUs, but pretty much, you won't see much in CPUs, right? Basically, it gets converted. Even if you have an FP16 data type for CPUs, it gets converted to FP32. So this one does a good job of already downloading the model in the right format, right? In the FP16 model format, if you have a GPU. There is something called device map. When you have multiple devices or the model is very large, it first tries to use the GPU, and if it cannot fit all the layers in the GPU, it can use the CPU, etc. also. So you just set it to auto so that it does the best job with the available hardware. Then we need the processor. As I said, that you need to do some pre-processing. And again, the syntax is so easy. Sometimes I feel that everything has been made so easy for the next generation. How will they know what it takes to write difficult code? But anyways, so you get the processor out, and we will use this processor to pre-process the data before sending it to the model. And finally, when you do model.device, it does everything needed. It downloads the model as well as sends it to the device, right? So this model needs to reside on the GPU, and it does all of that thing. And you can see here, it is downloading. Oops. So it's downloading all these models. Not this model, sorry, all these files which are part of the same model. And here you can see that there are two files, model 01.safe-tensors and 02.safe-tensors, and it is going to download both of them and load it in the right format. You don't have to worry about any of this, how exactly it is done. Okay. Next, we are ready to upload an image to this model and do some inference, right? We want to do image captioning. So we get an image. We are downloading it from the URL, and here we are opening the image. And for people, this, if you have programmed in Python, this must be familiar code. We are request downloads. It's used to download the URL, but this downloaded data is not in the right format. It doesn't look like a file system to the image opener. So this io.byte bytes io, basically it makes the data look like a file system, as if you're uploading from if you're loading the image from the file system, and you can open the image. After you open the image,
shout out to the Python requests library, one of the most useful libraries, I think, in all of Pythondom.
Yeah, that's absolutely true. So you can download it in one line of code. One other thing that we are doing right here is converting it to RGB format automatically, so that you're not you don't get the image in BGR format and then you have to do it again, right? Okay, so this is the image we have downloaded, and we want to caption this image. Now, as I mentioned, we have to create a message, right? And here we don't even need the system prompt, right? We can just it's a simple problem. We don't even need to provide any system prompt, and everything can be done using the user prompt. So message, we assign a role to it, which is user, and the content, we want to pass in the image, and we want to pass in the text. Describe this image. That is it, right? That's what a caption is. It's a description of the image. So we are instructing it to describe the image. Now let's see. Um, Oh, yeah. Oh, so this is, sorry. I was trying to think, why did I write this code twice? This is part of the markdown, and this is the actual code. So you run this, you store this in messages, and now let's look at what the chat template looks like, right? Uh, the a chat template is basically, we have written everything in JSON format, but this format is not something the model recognizes. Uh, it has a particular chat template, right? And we have to use this chat template. And the template has things like, right, when it sees in the template, in the string, it sees image start, role, content, etc. So you need to send it in this format. Fortunately, we don't need to construct this manually, but just to give you an idea, the JSON format that we created is not the one that would be used by the model. So we need to change the format. We still want to input in JSON format because that's convenient, but we want some code that will automatically change it, right? So you can see here, we do processor, and processor has everything done for you, right? You don't have to worry about it. And the fun part with this processor is that when you basically get it automatically, right, based on the model that you have specified. So when you're using transformer package, you can pretty much use the processor in similar ways without knowing exactly how it is doing things, right? So it's very consistently done. So you apply the chat template, you pass in the message, you say tokenize is false. And the reason we don't want to tokenize it right now is in the next, I'll show you in the next, when we actually send it, we'll turn on tokenization. But for now, we don't want to turn on tokenization. I want to see if we turn on tokenization, we won't be able to print. These things would all look like numbers, okay? Add generation prompt, right? What is the generation prompt? That also will be added, and we are going to print it, right? So you can see that image start system, you are a helpful assistant. We did not explicitly say it, but there is a system prompt which it automatically appends. It knows that, okay, you did not put in the system prompt, I'm going to put in the system prompt myself, okay? And then we have this next one which says, describe the image. So we are sending all this information. So this, you don't need to know exactly what is the chat template. It may be useful for debugging if you have special characters or something can go wrong. But most of the time you're working with this kind of a JSON message. But it's good to know that this is the input that the model is expecting, okay? So now we have, basically we are using process vision info. This is a utility that basically, if you look at the comment, it says it walks through every message. It finds all the instances of image and video, and then it applies Qwen VL visual pre-processing to ensure that the image is in the right format, the PIL.image format. And then it returns two parallel lists, right? And of image inputs, video inputs, and then also, it pre-processes both the text as well as the image. Oh, sorry, this one is, it pre-processes only the vision part, right? So you get image inputs and video inputs. It extracts from the message that you had created. And finally, we are ready, right? We are going to pass in, this is the input that is going to go to the model. So we use the processor, we get the text prompt, right? So this one is basically, the reason for these brackets is that it's a one element, right? It is only one text prompt that we are sending. And then we have the image inputs, we send in the video inputs. Padding, don't worry about it, set the padding to true, right? It basically, yeah, let me skip this thing. Set the padding to true. It is some little detail that it's not very important here. And then we have return tensor in PT. So transformer, it's a Python package, and it will work with TensorFlow as well. So we have to explicitly tell it to use PyTorch, right? So the tensors that it returns should be in PyTorch format. For people who are familiar with TensorFlow, you would know, and PyTorch both, you would know that the two formats are slightly different, right? The in PyTorch, the batch size comes first. The first element is the batch size, followed by the number of colors, followed by the width and height. In TensorFlow, the format is slightly different. I cannot remember exactly. I have not used TensorFlow for a while, but I think it is height, width, and then channel, and then finally the batch size. I may be wrong on that. All right. So now we want to use, okay, once you have done this, right, this input, you're passing it to the model, right, to the device, sorry. And this device we have already set to GPU, etc. So we had already transferred our model to the device, but here we are going to pass the input. We are going to push the input. Next, we have torch.nograd. Whenever you're using in PyTorch, whenever we are using some sort of, whenever we want to use inference, right? We want to make sure that the model is not generating all the gradients. So to make things faster, this nograd is used. Otherwise, it's going to calculate the gradients, and gradient calculation is necessary when you're doing training. But during inference, when you're just using the model, that calculation is not necessary, and it can unnecessarily slow down the model. And so basically, you wrap it in torch.nograd and say model.generate, and you pass in the inputs. And you also say max new tokens is 64. So this gives you a sense of, this caps the output to 64 tokens. Okay. So the caption would be, you can say, roughly 64 words maximum. Now, just to give you an idea what these tokens look like, we can do inputs. If you look at these input ID 0, this is the token, right? These numbers are basically tokens, okay? And you will see, so they are fixed length tokens, which means that if they have used all the tokens, they will start padding it, right? The padding equals true is basically, it says that pad with the same value, which represents the end of the string, so that the length is the same. Okay. So this is just the input, and now we are going to do batch decode, right? The output that we get, right, the generated IDs that we get, it is not in a format that we can read. So we want to convert this. We want to convert this to a caption that we can actually read. Okay, and there could be some special tokens that we want to skip. And if you look at this, after all this thing is done, and we are printing this, this is the output you receive. The image depicts a serene and picturesque scene of a white dog sitting on a stone pathway near a stunning lake. The lake has crystal clear, sounds very reasonable. So you can see very few lines of code, and you are able to do something as sophisticated as image captioning. I was planning to go over the object detection notebook as well, but I think we are running short on time. So we will skip that. But if you register for this course, you will be able to see the object detection notebook also. We cover that in the free course. So just do a Google search on OpenCV.org, or Google search on OpenCV VLM Bootcamp, and you should be able to get it.
All right. Maybe if people really want it, we'll do a whole episode on that.
Yeah, that's another option.
If folks are really interested, send an email to newsletter@opencv.org and request it.
Yeah. All right, so let me stop sharing my screen. If anybody purchased the course in the last, during this hour, please send us an email at courses@opencv.org so that we can send you the additional free gift, which is a book by Francois Cholet, Deep Learning by Python. It is not included in the current thing you have. I also want to say, we also have a webinar that we will do on, let me share my screen. So we are running this on the last day of our of this this event, this sale event. We will have this webinar that starts at 5 p.m. Pacific time, and we will go over what the courses are, everything. We will go over this, and you will also learn why should you do computer vision now, all sorts of things. So sign up for this webinar at opencv.org/webinar, and this is the last day of the sale event. So we will basically be there for as long as it is necessary to answer all the questions, right? So 5 p.m. Pacific time, September 2nd, 2025. Sign up for this webinar. I'll be there I plan to be there till the end of the sale event, which is midnight Pacific time. So we'll start at 5 p.m. Pacific time. I'll be there throughout. We will be talking about many different things, how to start a career, but also about various other things, right? How do you actually in a real world scenario, how do you go from various steps, right? Model deployment, this and that. So many of these things we will cover in that webinar as well. So opencv.org/webinar.
Yes, and sign up. These things are free, folks. It's amazing that they're still free. Maybe Satya will start charging for these at some point, but that day has not yet arrived.
Yeah, and full disclosure, this is the last day of the sale.
Right.
So there will be selling involved, right? There is information involved, but there is also selling involved. I just want to be upfront that it is not this kind of webinar which is only educational. It is educational plus selling. You have been warned.
Hey, we try to be honest with you folks out there. So, and speaking of honesty and speaking of free stuff, I think now is a great time to do our giveaway. So I'm going to go ahead and, in fact, bring our chat up on the stream here. Unfortunately, I can't put our Zoom chat up on the screen, but I am monitoring it in a separate window.
Okay.
So the way this works is I'm going to ask a trivia question based on today's presentation, and the very first person to answer that question correctly in the chat, either on LinkedIn, YouTube, Twitch, or on Zoom. Also, Satya, there's a typo in your link there. It says webinar, not webinar.
In the link.
Thanks for that, chat. I appreciate it. Yeah. We will. So the way this works is I'm going to ask a trivia question based on today's presentation, and the very first person to answer that correctly will win the OpenCV University course of their choosing. You can go to opencv.org/university to see what courses are on offer, or you can scan the QR code that I've just put up on the screen right under our faces here if you're watching on the live stream. Transform your career with computer vision, deep learning, and OpenCV courses at OpenCV University. Go ahead and scan that QR code. I'm going to remove the chat here for a moment and talk a little bit about our sponsors for today's episode. Today's episode is brought to you by OpenCV University, as Doc talked about a little bit earlier. There is, in fact, a fantastic sale going on OpenCVU. You can go to opencv.org/university to get the Labor Day sale for just 17 hours, 22 minutes, and 52 seconds longer using code LABOR40. That's LABOR40 for 40% off all OpenCV programs and courses. That is a huge chunk of savings. Don't miss out on it. That's opencv.org/university. This episode is also brought to you by and partners. OpenCV is a nonprofit organization that puts out free open source software, and as such, we depend on the support of organizations just like the ones on your screen right now. Big shout outs to ARM, Qualcomm, RunPod, Intrinsic, FutureWay, JetBrains, RoboFlow, Hackster, 7 Cents, Google Summer of Code, OpenMV, our newest bronze member, Orbic, Tangram Vision, Amped Software, Intuitivo, Rerun.io, the Edge AI and Vision Alliance, and Big Vision. If your company uses OpenCV and wants your name to be listed amongst these industry titans, please send one email to phil@opencv.org and we'll get talking about it. OpenCV membership has a program we've designed for companies of all sizes, whether you're a new scrappy startup or whether you're a huge established company like ARM or Qualcomm, or whether you're somewhere in the middle like RoboFlow. OpenCV membership has a plan that will work for you, and you'll be able to help support the library that you depend on. OpenCV is also supported by our sponsors on GitHub.
By the way, your screen...
We've got 14 of them right now. What's that?
Sorry, the screen had not changed.
We're having some local internet slowness here. We'll figure it out. Yes, so we're also supported by our GitHub sponsors. You can go to github.com/sponsors/OpenCV and be as cool as Christopher. Man, this to me looks like maybe a Polish name. I don't know if I can do this one. Piraski. We've got Tegan Burns. We've got LivePeer. We've got the homies at RoboFlow, double supporters of OpenCV. Jesus Anaya, DJ Greenwood, iPop.ai. We'll have to have them back on the show sometime soon. Comet ML, Jonas Heinle, Alexander Ismailov, Tala Hussein, Nick Libertini, Blue Jay, and Ruddis Laboratories. We're also brought to you today by OpenCV's official merch shop at opencv.myspreadshop.com. We recently slashed prices on everything on the shop. It is now about 50% what it cost just a few weeks ago. For example, iconic import statement on a shirt, if the page for me, we'll see. We'll see. $3 versus about the $40 that we had it set as last time. Our thinking with this was, if you want an OpenCV shirt, you really want for the import CV2 shirt on a very comfortable 100%. We've also got the OpenCV items of clothing, also tote bags, pins, fridge magnets. I love OpenCV in English, simplified Chinese, and in Espanol. Yo amo OpenCV. You can buy these things at, once again, opencv.myspreadshop.com, or you can scan the QR code that I just put up on the screen. $23 for a pretty sweet OpenCV t-shirt. Since we dropped the prices earlier this week, we've actually sold twice as many shirts in the last week than we sold in the last year. So feeling pretty good about it.
Really?
Yeah.
Okay, well, if you drop the price by this much, I think we are definitely not getting any donations, really. But it is good advertisement for OpenCV.
Yeah, it's promo, right? I think at this point, inside baseball, I think we make about $5 a shirt or something like that. So, it's not that much, but it is cool to see people like at your CVPRs or these conferences we go to wearing OpenCV gear. So, buy a shirt. You are supporting OpenCV in your small way, and we really do appreciate all of these ways for folks to donate.
Before the end of this year, we will also produce an OpenCV 25-year limited edition T-shirt. So stay tuned for that.
Yeah. Or possibly even a challenge coin if you're into that. We were just talking about this. But okay, it is now time for the trivia giveaway. First person to answer in the chat wins the prize. Somebody on YouTube already tried to answer the question before I asked it. Bad news, you're wrong. But I appreciate your gumption. I really do. I think trying to get in my head is not easy. Oh wow, somebody just said they're buying 10 shirts for their staff at work. Hell yeah.
Oh wow, thank you so much.
Thank you, Carlos. We really appreciate that. So we have talked about Qwen 2.5-VL today. If you've won in the last couple of months, please do not answer and give someone else a chance to win. By the way, if you're answering on Zoom, everyone, and not just hosts and panelists, if you're watching anywhere else, just post it in the chat. I've got both of these windows up right now. We've talked a lot about Qwen 2.5-VL today in 2.5-VL release. What month and year? Both parts of the answer to win here today.
You got me this time.
You're close, Lawrence.
I think this is the first time you got me. I don't know the exact.
Oh, hey, we got it. It looks like look in here. I see Pamudu over on Zoom just answered 5 January. That is indeed correct. It was January 28 official Alibaba blog. So congratulations. I know we're having a little bit of sorry, folks, but the good news is the lagginess applies to everybody. Zoom is getting the same lag as YouTube, is getting the same lag as Twitch, and so it is what it is. But yes, some of you folks out there also got the right answer. Pamudu is our winner for this week's trivia giveaway. Please go to opencv.org/university. Pick out a course, send me an email, that's Phil, P-H-I-L, at opencv.org with the name of the course that you would like, and we will make sure you get that added to your OpenCVU dashboard. Congratulations, Pamudu. We've got a few questions here, Doc, while we, before we wrap up here. Somebody asks, can you send t-shirts overseas to Angola? I don't know about Angola specifically, but if you go to the opencv.myspreadshop.com and add something to your cart, it'll have a list in the checkout of countries they do ship to. And I know it ships pretty fairly, like almost all over the world, where it's like possible to get stuff into, basically, without greasing some palms, as we've talked about on this show over the years. So thanks for your interest, and hopefully we can get you a shirt. Got a couple of questions here saved. Let me go ahead and I'm going to drop off my face so Doc can answer some of these questions himself here. Here's a good one from earlier in the stream from Shan. What are some common mistakes if an image is not classifying correctly, and how can we fix them?
Well, so if it is not a VLM, right? In a VLM, you can use a better prompt, right? So you can say that, let's say, it doesn't happen, but let's say a simple example, right? Let's say it gets confused between a dog and a wolf, right? Then you would run your, the prompt, you would change that, pay special attention, right, to dogs and wolves, right? So most of the things with, you want to first use prompt engineering to get this image classifier if you're using a VLM, right? If you're using a VLM, it is tricky because this is a large model, right? You don't want to jump into fine-tuning immediately. So you want to do something using prompt engineering as much as you can. So you would give extra prompts for classes it is getting misclassified with, saying that pay special attention, or make sure that you don't do this, do that. So it does, those kind of prompting does affect the final output. But you can also fine tune the model to give better results, right? So you can add image caption pairs to improve the quality of the output. But in standard image classification, right, the best way is to just fine tune the model, right? Because those are not difficult to fine tune. They're pretty easy to fine tune. Just wherever it's getting confused, let's say it is getting confused between dogs and wolves, take those examples, the hard examples. This is called hard negative mining. So you take the hard examples and put it in the training set and fine tune, right? It's as simple as that. Find all the hard examples where the misclassification is happening, and then fine tune the model again. And that pretty much fixes the problem most of the time. So if you're using standard image classification network, the mistake you have made is that your training data is not rich enough, right? So you basically fix your training data. Phil? Where's Phil? Sorry, guys, we are having some technical issues today because of the network. Oh, let me see if I can find some questions. All right. Okay. Komil says, can we please have a session on Qwen Image Edit 2? Point taken. We'll see when we can fit that in. So we basically we have a very packed schedule for the next few weeks. So whenever we have some guest drop off or something happens, then we modify that session to a tutorial session. But I'll look into it, how much time it takes to fit that in. And if it is in 1 hour, we can fit that in. We'll definitely try to do that. That's a good request. Thank you. All right. So I'm not sure what's going on right now with the network issue. So, but we are close to our program already, and I have a hard stop in just a few minutes. So let me conclude this show, and thank you, Phil. As I said, that if anything goes wrong, it is his. Phil organizes this show, and if anything goes wrong today, it came true finally. Oh, you're back.
Yeah, for some reason, it put my screen up as well. I don't know why it did that. Yeah, sorry about that, folks. We had a total internet dropout here in Tijuana. So I think it might be because it's raining a little bit out there. Anyway, thank you. Yeah, Camille. Maybe we will have a Qwen image edit tutorial here. I'm pulling up the chat. I think we had at least one more good. Unfortunately, we just lost Zoom. Sorry, folks. Yeah, I think we're just fizzling out here.
It's okay. I think we can conclude today's session, and the questions we can answer by email.
Oh, son of a bitch.
Phil, you're online. All right. So Phil thinks that he is offline, but we are online. And so I just want to thank everybody who is here today for this webinar. Thank you so much. And also our sale is going on. If you're interested in the OpenCV University courses, which are your guide to become an AI engineer, please join today. This is one of the best deals you can find. And if you purchased a program during this webinar, please send us an email at courses@opencv.org, and we will be able to, you'll receive the free book. All right. That's it. Thank you so much. Thank you, guys. We have to conclude this and unfortunately, Phil is not here because of network issues, but we'll see you next week.